Hello and welcome to lesson 5.4, solving proportions. Yay, we finally got here. We've talked about whether or not two ratios form a proportion, we've looked at graphs, we've written proportions, and now we're finally going to solve them. It took us a while. We finally got here. So there's a bunch of different ways we can do it, and we've sort of gone through a lot of these already, so this isn't going to be that difficult. You can use mental math. 7 times 3 is 21, so 5 times 3 would be 15. You can use the multiplication property of equality, which I'll show you. And we can also use cross products. 5 times 21 is equal to 7 times x. Divide both sides by 7, and x is equal to, well, whatever that is. But we'll start with the multiplication property of equality. So basically, this is just solving... Yeah, I got it right. Solving the actual equation. So 7/5 is equal to x over 21. Well, how do we isolate x? Well, we multiply it by 21 on both sides. This simplifies, so you're left with x. And I'm going to cross simplify because I'm lazy. I don't like to multiply 21 by 5 and then divide by 7. That seems like a lot of work. So 21 and 7 are both divisible by 7, so 7 divided by 7 is 1. 21 divided by 7 is 3. So 3 times 5 is 15, so x is equal to 15, which is kind of what we figured out with mental math. No, there's no specific way to solve this. You can use any of these methods as long as you get the right answer, unless the instructions say to solve it a specific way. So here's 3 examples. Why don't you try them on your own, pause the video, and then restart it and see where we got. So hi, welcome back. So the answers to the on your own, W, number 1, W is equal to 4. Multiply both sides by 6. Simplify and you end up with 4. In this case, A is equal to 18. Again, multiply both sides by 15. Do some simplification and you get your answer. And 3, y is equal to 3. Multiply both sides by 6. Y will equal to whatever that is when you, well, 3 when you simplify it. So example 2, solve proportions using a cross product. And this by now we should probably know how to do since we've sort of done it a lot. So in the case of solving by the cross product, we have 8 over x is equal to 7 over 10. And remember, it's that little butterfly method. So 10 times x is 10x is equal to 8 times 7. Simplify, so 10x is equal to 8 times 7 will give us 56. Divide both sides by 10 because we're going to solve for x. And x is equal to 5.6. And if you look closely at this, this is really, if you multiply both sides by 8, you end up with 56 divided by 10. Kind of the same thing. In this case, 9 over y is equal to 3 over 17. We're going to take the cross products. So 9 times 12 is equal to y times 3. 9 times 12 is 153. Yes, I used a calculator. Is equal to 3y. Divide both sides by 3, and using the calculator, I get y is equal to 51. So on your own, why don't you try these 3 using cross products and see where you get. Well, in this one we get, it has to be all the way down here. X is equal to 8, because you're going to take 2 times 28 and divide it by 7. Y is equal to 2.5. You're going to end up with 12y is equal to 30. Divide both sides by 12, and you get 2.5. This one's a little bit more tricky, and I'm going to draw an arrow way up here so that we have some room. Okay. The cross product of this is going to give us 6 times 40, times 40, is equal to 15 times all of z plus 1. You have to remember your distribution property here. So 6 times 40 is 240. And now we're going to distribute the 15 onto everything inside of the parentheses. So 15 times z is 15z, plus 1 times 15 is 15. Well, now we have a two-step equation, so we're going to subtract 15 from both sides, and we end up borrowing. So 10 subtract 5 gives me 5, 3 subtract 1 gives me 2, 2 subtract 0 gives me 2. And these cancel out, and I end up with 15z. I'm going to divide both sides by 15. I'm going to end up with z is equal to 15, because 15 times 15 is 225. So the only thing tricky about that is you have to remember that this 15 is multiplied by the entire expression here of z plus 1. So you have to use the distribution property. Okay, on to the next page. So here's a real life application. The graph shows the toll Y due on the turnpike for driving X miles. So the toll is the dollars and the distance is the miles. Your toll is $7.50. So we're here at this point. So it's $7.50 and you drove 100 miles. Okay. So the point 107.5 on the graph shows the toll of $7.50 for driving 100 miles. They want you to convert the miles to kilometers. Well, there's two ways we can do this. So method one is to convert using a ratio. So I can say 100 miles times 1.61 kilometers per every mile. So this is kind of like a unit rate. 1 mile is 1.61 kilometers. And if I multiply this out, the miles cross out, and I'm left with 100 times 1.61, which will give me 161 kilometers. So that's one way of doing it, and this is using a ratio. Because remember, this is a ratio of kilometers to miles. Second way is to use a proportion. And I'm going to say 1.61 kilometers to 1 mile, and that's that proportion. And we don't know what the kilometers are. That's what we're trying to figure out. But we do know that the miles are 100. So we can use the cross product here, and we're left with 100 times 1 and 61 hundredths is equal to, well, x times 1 is x. So 100 times 101 and 61 hundredths is 161 kilometers. So x is equal to 161 kilometers. And you can see that we get the same answer. So thanks for watching.